Now go to the question number 6, cover missing values and logistic regression. So the question number 6, A part, three approaches to handle missing values. So the first is deletion. So simply remove row and the column with missing value. Simply, but you lose information using when you use missing data is minimal. So imputation, then imputation filling in missing value will the second is implementation filling in missing value. You can use statistical measure like mean, median and mode, or use more advanced method like knn implementation or regression based prediction. And the third is indicate variable. Indicator variable creates a new binary column that's flag uh, whether a value was missing. This preserves the information that its data was missing, which might itself be meaningful. For now, let's go to the question number 6 B part. Let's work through a logistic regression example. So the problem predicts if a student pass an exam, yes or no, based on study hours. So the logistic function is P for of pass equals 1 divided by 1 plus e to negative so of beta 0 plus beta 1 times x. So the given beta 0 equals negative for beta 1 equals 1.2 and study hours x equal 5. First calculate z. So z equals negative for plus 1.2 times 5, which equals negative for plus 6 equals 2. Then p of pass equals 1 divided by 1 plus e to the negative. So 2 is about 0.135. So p of the pass equal 1 divided by 1.135, so which is equal to the 0.88. So the our percentage is 88%. 88%. So the student has an 88% probability of passing if they study 5 hours. This S-shaped logistic curve is perfect for binary classification problem. So now go to the question number 7. So question number 7 ask about k-mean clustering and knn clustering classification. For question 7a, the k-mean algorithm has these steps. So step number 1, choose k, the number of the cluster you want. Second, initialize k random point as you initial centroid. Now the third is assign each data point to the nearest centroid. Now this step number 4, recalculate each centroid as the mean position of all the points assigned to. And the question step number 5th, repeat step 3 and 4 until the centroid stop moving. This convergence. Now initial centroid have a huge influence on result. Best not bad initialization can lead to the local optimal where the algorithm get stuck in a suboptimal solution. The solution is to run k-mean multiple times with the different random initialization and choose the best result, or use k-mean plus which is a smarter initialization method. So now go to the question number 7 B part. So let demonstrate knn classification. Say we have a it's a we have a so the question number 7 B part it says let demonstrate knn classification. Say we have a 5 data points when coordinates with the label, and we want to classify a new query point at the coordinate 3 and 4 using k equals 3. So the first step, you calculate the Euclidean distance from the query point to all existing point. The second point is identify the 3 nearest neighbor based on the those distance. Now the third step is take a majority vote among these three neighbors. For example, if two neighbor have level A and one has level B, we predict the query point is class A. So KNN is a non-parametric, simple and effective, but can be slow and large data set. Now let's go to the question number 8. So question number 8 compare ensemble method and cover neutral network logical gate. So let's compare the three important method decision tree. So they are the highly predictable. You can see the decision rule. They have a handle non-linear relationship well. Weakness, they tend to overfit, and they have unstable simple small data change can produce very different tree. So first is random tree, and then second is random tree. Random tree strength, they reduce overfitting by averaging many trees. They achieving high accuracy on complex problem. The third weakness, the random tree weakness is less interpretable than single tree, computationally expensive with many trees. Now the third is boosting method, like ADA boosting and gradient boosting. Strength is often achieve the highest accuracy by sequentially improving on the weak model, and the weakness is more prone to overfitting than random forest, slower to train because it's sequential not parallel. Now go to the question number 8 part B. It building logic gate with neutral network. So the table shows and not gate need one to two neutrons with step or ReLU activation. All needs back propagation for training. So but our XOR is a special, it requires three or more neutrons including a hidden layer, because XOR is not linearly separable. You can't draw a single straight line to separate XOR input. This is actually a historic milestone that discovered that single layer presentron could not solve XOR, lead to development of multi-layer neutron network. Now let's go to the question number 9 is about decision tree using information gain. This is the computational heavy, so pay attention. So the question number 9 A part, we have a given data set with 14 records, and we need to find which attribute gives the best first split. So the first step is calculate the entropy of the target variable. By computer, we have 9 here and 5 no out of 14 total. Entropy of S equal negative 9 over 14 times log base 2 of 9 over 14 minus 5 over 14 times log base 2 of 5 over 14. This is equal 0.940 bits. So the step number 2, calculate information gain for each attribute. Let's go edge as an example. So edge has three values: youth, middle and senior. So the youth 5 records, 2 yes, 3 no. Entropy equals 0.971. Now for middle in the middle we have 4 records, and the 4 records for yes and no 0 1, means 0 no. So entropy equals is 0.000. So the perfect priority. Now for senior we have a 5 records in which 3 yes and 2 no. So the entropy is 0.971. Now the weightage is average entropy equals 5 over 14 times 0.971 plus 4 over 14 times 971 and equals 0.694. Informative gain for h equals 0.940 minus 0.694 equals 0.246. So you could repeat this for income, students, and credit rating attribute. So now go to the question number 9 p part. We calculate Gini index. So instead of information gain, the Gini index formula is Gini of S equal 1 minus the sum of pi squared for all classes. For the root with 9 yes and 5 no, Gini equal 1 minus 9 over 14 squared minus 5 over 14 squared, which equals 0.459. You calculate Gini for the each split similar to the how we didn't information gain. Then choose the attribute with the lowest weightage Gini index. For ninth C part, we need to draw two decision tree. So in the two decision tree, one using information gain, and one using Gini index. Then compare them. So tree 1 using information gain. So in the information gain, you start with the attributes that has the highest information gain as the root. Then recursively split until you reach pure leaf node or stopping criteria. For tree 2, use Gini index. Similarly process but using Gini to decide split when comparing the final rule. So information gain trends to the favor attributes with more categorical. It's best towards high credibility feature. So Gini index tend to the create more balanced split and is less biased. For both tree might have slightly different structure, but their final prediction accuracy should be similar. In practice, both methods are effective, and the choice often depends on implementation preference. And the conclude our the end same solution. We covered the complete data science pipeline from methodology to advanced modeling techniques. Make sure you understanding not just the answer but the reasoning behind each solution. The concept being built on each other. If you have a question about any topic, please drop in the comment below. Don't forget to like, subscribe, and more data science tutorial. Good luck for your exam, and thank